download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about changes of state. Now it's important to note that a substance is solid at temperatures below its melting point. It's a liquid at temperatures between its melting point and boiling point, and it is a gas at temperatures above its boiling point. So let me just use the example of water to help explain this. Water has a boiling point of 100 degrees and it has a melting point of 0 degrees. If water is below its melting point, i.e. below this, it will be ice. It will therefore be a solid. If water is between its melting point and boiling point, so between 0 degrees and 100 degrees, it will be liquid. So it will be water. Because it's not cool enough for it to melt, but it's also not hot enough for it to boil. So it will be a liquid. And if water is above its boiling point, it will be vapour, water vapour. So it will be a gas. It would have boiled. So using that, what I want you to do now is to have a go at these questions here to test your understanding. So pause the video now. Okay, let's go through the answers. So for question 1, which metal has the highest boiling point? You should have had iron at 1540. Which metal has the lowest melting point? It should have been mercury with -37. Which metal is a liquid at room temperature? Well, it is mercury. Okay, it's -37, therefore it will be a liquid at room temperature. Because it's not hot enough for it to boil, but it's not cool enough for it to melt. Which two metals would be liquid at 100 degrees? That would be sodium and mercury. And finally, which state would iron be at a temperature of 900 degrees? It would be a solid. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. So in a previous video we looked at the states of matter. Now what we're going to do is we're going to look at what happens when the states of matter change. Now it's important to note that a change in state is a physical change rather than a chemical change. This means you don't end up with any new substances. It's the same substance as you started with, just in a different form. So again, if we take that water, if we melt it to ice, it's still water, but just in a different form. So what I'm going to do is we're going to start off with our solid. And you'll remember we drew our solid like this. To get that solid into a liquid, to make it like this, is called melting. Okay, so from a solid to liquid, it's called melting. And then from a liquid to a gas, which remember looks like this, is boiling or evaporating. And then to get it back from a liquid to a solid, so to get it back from a liquid to a solid, is called freezing. And to get it from a gas back to a liquid, it's called condensing. And from a solid straight to a gas, we call it sublimation. But what is actually happening? Well, when we have our solid and we melt it, we are increasing the temperature. And therefore the particles are starting, the force between the particles is starting to get weaker and it's starting to form a liquid. And again, as we got our liquid, we are increasing the temperature. And then the particles therefore gain energy and the bonds between them start to get weaker and then they form the gas. And it's the same in reverse. If we cool down a gas, the particles lose their energy and become a liquid as new bonds form. And the same as we cool a liquid, it becomes a solid as the particles lose energy and form bonds. Now we do need to remember the names of each of these state changes. So what I'd now like you to do is have a go at answering these questions here. So first of all, looking at the diagram, label A, B, C, D and E, and then tell me what is happening to the particles in the substance when change C happens. So pause the video now. Okay, let's go through the answers. So for A, you should have melting. So from solid to liquid is melting, and for B is freezing. So liquid to solid is freezing. And then C, you should have evaporation or boiling. So liquid to gas. And D to solid gas to liquid is condensation. And E is sublimation. And then for question 2, what is happening to the particles in a substance when change C happens? Well, C is evaporation. So we are providing more energy, we are heating it, and therefore the forces of attraction are overcome. The particles are becoming more free to move in a random direction, and therefore spacing between particles increases, and it becomes a gas. Now, when a substance is melting or boiling, you're still putting in energy, and so increasing the internal energy. But the energy is used for breaking bonds between particles rather than raising the temperature. So let me explain to you what I mean by using this graph here. And along the X we've got time, and along the Y we've got the temperature of the substance. So we're going to start with a solid, and as we are increasing the temperature over time, the temperature is going to increase. So at this point here, our substance is a solid. When that gets to its melting point, so when the solid reaches its melting point, we are still going to be increasing the temperature and putting in more energy, but the temperature of the solid is not going to change, as we can see here with this plateau. This is because the energy that we're providing it is being used for breaking the bonds between the solid. So we're breaking those bonds for it to become a liquid, and not to raise the temperature. So at this line here, it's representing melting. When all the particles have melted, the temperature will then start to rise. So again, we're increasing the temperature, and the temperature of the substance will start to rise. But at this point, it's now a liquid. Again, when that reaches its boiling point, so when whatever solid it is reaches its boiling point, we know that it will start to change state into a gas. But again, our increase in energy is not going to raise the temperature of the substance. It is going to go to breaking the bonds. So again, the line plateaus. The temperature is not increasing because the energy is increasing and going into breaking the bonds. And this here represents boiling. And we're trying to get it from our liquid to our gas. So again, our energy is going to breaking these bonds and then not to increase the temperature. And again, when all of those bonds have broken, the temperature will start to increase again. And at this point, it will be a gas. Now, when a substance is condensing or freezing, bonds are forming between the particles, which releases energy. This means the internal energy of it will decrease, but the temperature doesn't go down. So again, let me explain in terms of a graph. And again, we've got time and we've got temperature. So this time we're starting with a gas, so the temperature is going to be high, and we are decreasing, the temperature of the object is decreasing. And at this point, it's a gas. Now, when it reaches its boiling point, so when it reduces its temperature and reaches its boiling point, it will start to condense. But again, this change will not go to reducing the temperature, but it will go to releasing energy to form new bonds. So new bonds will be forming between the particles. So at this point here, it will be condensing. And when all those new bonds have been formed, the temperature, the internal energy will start to decrease again. And at this point here, it will be a liquid. And again, this internal energy will decrease up until its melting point. So melting point. And now the decreasing in energy will not decrease the internal energy. The temperature doesn't go down, but it will go to forming the bonds. And this will be freezing until all the new bonds are formed, and then it will now be a solid. So as then we reduce the energy input, it will be the temperature will go down. The energy needed to change the state of a substance is called latent heat, and we will look at that in a future video. So now what I'd like you to do is have a go at answering these questions here, and then pause the video, and then we'll go through the answers afterwards. So pause the video now. Okay, so let's go through those answers. So for question 1, C is a liquid and E is a solid. And then name the processes that are happening at B and D. P is condensing and D is freezing. Explain why the graph is flat at points B and D. Well, energy is being used to form bonds between the particles. This gives out energy, and so the temperature does not fall. And then question 4, describe what happens to the arrangement of particles as it goes through state change D. Well, transition is from a liquid to a solid. The forces of attraction between the particles strengthen. Particles are now arranged in a regular arrangement. Particles are no longer free to move and therefore vibrate about a fixed position. So we've now looked at changing state. You can now use the quizzes and exam questions to test your knowledge on this topic. If there's anything you didn't quite understand during this video, then please do get into contact with one of our tutors who will be happy to help.